All right. Thank you everyone for joining this sixth lecture of the Java class. Um, Hope you guys are having a good President's Day. Let's see what we have today. Let me share my screen. Okay. So the topic of today's lecture is going to be arrays. But before we get into that, let's do a quick review of strings. Uh, so let's see. Equals versus double equals. The equals method is content-based. The double equals is memory or reference-based. That's the main difference between the two. String object is we could think of as a more powerful version of the string literal. So you can do more with the string object. It takes more places, more space in memory. There are some things that work with string object that don't with string literals. Um, let's see, this part of the slide here gives an example of how to use the substring method. So when you just give it one argument like this, where it's just 5, it goes to the 5th index, um, and takes everything at the 5th index, and after that, so C would be equal to uh, all we are now in the hall. And the split method for strings, it it takes the argument that you're putting in and makes an array where the elements in where the first element is everything before the split and the second element is everything after the split. So we haven't gone over arrays yet, but we are doing that today. So does anyone have any actually so does anyone have any questions about strings before I do a quick review of the homework? No. All right. So for the homework, let me quickly pull up the instructions for the homework. So the instructions was to uh, write code to find the last index. Actually, no, let me just pull up the whole thing. I'll make it easier on everybody. Okay. So this is the homework from last class. So we were given a sentence, please compare Tom and Mary in the classroom. The assignment was to use the substring method to extract the two names in the sentence. And it should work regardless of what sentence you put in. And there were extra stuff in the homework, but I felt that, okay, and the other part was the use of the length method, and to print out whichever name comes first in the alphabet. So I in the Google Classroom, I told you guys that you can leave out the last two parts of the homework because I felt like we didn't go over um the needed material for that. So you can do it as a bonus if you'd like. But the main thing was to use the substring method to get the names. So here is my solution to the homework assignment. Uh, I declare a string. Please compare Tom and Mary in the classroom. And then I make two string variables named 1 and 2. That's Tom and Mary. And then I use the index of method for strings uh, to get the start and end positions for both name 1 and name 2. And then use the substring method to finally extract name 1 and name 2. So running this whole piece of code here, we get Tom and Mary. And this code works regardless of what I put in. So if I were to put Kingsley and uh, Kingsley and Alex, and all I have to do is just change Kingsley and name 1, and Alex in name 2, and the code still works regardless. It's still able to extract my name and the other name and print them out. So does anyone have any questions about homework 5, I think this was, from the last class? No? All right. All right. Well, let's move on to the material for today's class. All right, arrays. So as we've seen, there's a method for strings that's called split that returns an array. So as we see here, string and then brackets and then y defines variable y as an array. Then the question is, what is an array in Java? Well, an array is a container object that holds a fixed number of values of the same type. The length of an array is established when the array is created. After creation, the length is fixed. So string straight brackets y means y is a type string. So we could, in easy terms, think of arrays in Java as just a list. As just a list of a specific data type. So an array could be a list of ints, could be a list of cars, and a list of, it could be a list of strings, a list of anything. You could even have arrays of arrays. That is what an array is. And we could see in Java's main method here that it actually takes in an array of strings as an argument. So this is what the slide was talking about earlier about arrays being in. Yep.
Does that mean that means whatever you write in there, it takes in both strings and like in arguments?
It essentially means that the main method in Java takes an array of strings as arguments. Yeah. So this is more relevant when we're running Java from the command line and we give it arguments to start off with. And there are ways that you could take in the arguments that someone puts into the main method. But since we're using an IDE, it's not as relevant to us. All right, I hope that answers that question. All right, so there is a specific way to declare, a specific syntax really to declare an array. There's this data type brackets array var name, which is the way that most people do it, this first way here. There is also a similar way where you put the brackets at the end. That works, but you don't really see a lot of people do that in practice. This third way here to do it's the same way as the first two, but the way that it works behind the scenes in Java is kind of different, but from our perspective, it's pretty much the same. This syntax where we have data type brackets, array var name is equal to, and then curly brackets, and then a bunch of values. That's another way to declare an array. So we could see some examples of all of this as we go along in the class. So this is one way to declare an array. This is equal to like the last way that we saw earlier in the last slide. This way with the brackets at the end. Let's try to declare this array and see what happens. All right. So according to this, we are making an array of doubles because we're declaring a double variable here. And then we have two brackets, and then our variable name is here. Variable name is my list. And then we have curly brackets here, and then we have our list of double variables that we're putting in. So if we were to try to print out my list, let's see what it prints out. Oh, well, that's interesting. Okay, I think I see why I did that. So let's go with the first index here. Okay. All right. So just trying to print out the variable name as is. It just prints out what looks like nonsense to us, um, because we have to put in an actual index. We'll be talking about indices soon enough. But this right here, this first line, this line 7 is one way to declare an array. And in this case, it's an array of doubles. Well, does anyone have any questions about declaring arrays? Oh, all right. And this graphic here kind of talks a little bit about what's happening behind the scenes when you declare an array in Java. The variable my list is just a reference to the array, and then you could access the actual values in the array with the brackets, square brackets, and then the number and index value of it. So the first index value in an array is always it starts at 0, and then the last one is just the length of the array. So 5.6 in this array is at index 0, 4.5 is at 1, 3.3 is at 2, and so on. Kind of similar to strings. All right. So to access an array element by referring to the index number, say my_list5 in our example, uh, so that's essentially how you access a value in an array. So if you want to access the fifth element in this array, or really if you want to access uh, the the value at the fifth index of this array, which would be 0, 1, 2, 3, 4, 5. It should be 34. Let's see. Yep, okay. So 34.33 is at index 5 of this array, or the sixth element, because we're starting from 0 when we're counting. So that's how you access an array and access an element in an array in Java with this bracket syntax, with the bracket and the number. To update a specific element, assign a new value to that element. You could do something like this. You take my_list0 is equal to something else, and that changes it. So actually, let's do something. Let's do something fun. Let's change the fifth element of this array, and we'll see how it changes. So we're printing out the element at the fifth index of my list, and then we're changing it to 10.2, and we're printing it out again. So let's see what happens. All right. So first it was 34.3, now it's 10.2. That's because we changed it. Is there any confusion about what just happened here? No? All right. Oh, we have okay. So the reason why we're getting all right. So what this syntax, my list is equal to brackets 5. What this syntax means is that we want to get the element at the fifth index of my list. So remember that when we're counting indices in a list, we're always starting from 0. So 5.5, this first element here is at index 0. And then 4.5 is at index 1. 3.3 is at index 2. 13.2 is at index 3. 4.0 is at index 4. And 34.5 is at index 5. So that's why when we did print my list 5, we got 34.33. Okay. So there's a difference between an index and a number's position on the list. So 5.6 is the first number in this list, but since indices in Java starts counting from 0, 5.6 is at index 0. It goes from 0 all the way to up to k, with k being the last element in the list. Hope that answers that question. So we just gave an example how to access an element in an array and also change an element value in an array. So an array has a property length. It is the size of an array, namely how many items are in this array. So if we try to run this line here, we can see that this element has 10 elements, that this array has 10 elements in it. We could count this one by one. I'll let you guys do that later. And we could find out the length of an array using the dot length property. So keep in mind that it's not a method. Like this would be a method when we add when we add the parentheses to it. But since this is an array, we could just put dot length to get the length of the array. Okay. See what we have in next. All right. So arrays have a class level static method. Let's try one out. What does class level static method mean? We could think of it as just one, I guess, a universal thing that all arrays share. Ugh. So let's see. I think I need to import something. Wait, hold up.
You have to import arrays.
We may have to. I'm just doing some Googling right now. Well, okay. So you generally don't have to import arrays, but when you're using certain, I guess, methods on arrays, certain functions, then you will have to import them. All right. Okay, that's my issue. Okay, so I just imported java.util.arrays, which would allow me to use the arrays.sort method down here. So let's see what arrays.sort does. But before I do that, I'm going to change this so that it's correct. Okay. So let's see arrays.sort. Okay. So by doing arrays.sort, we get 3.3, which is the smallest element in this array. So what arrays.sort does is that it just sorts the array that you're given it, which is my list for us. Let me just do some formatting here. Okay. Yeah. So by sorting, so first we sorted the array, and then we printed out the first element. Oh, what's this doing? Oh, that's weird. Let me fix this quickly. We have a question. How do you do descending sort? There's probably going to be, I don't really have the method at the top of my head, but I imagine it's going to be something like uh, descending equal true, maybe? No, it didn't like that. Uh, Descending can be resolved. Yeah, I don't really remember off the top of my head, but it's definitely possible. But there is a way to sort arrays in descending order rather than ascending. So by default, it does it by ascending order. That's why when we sorted this list and printed out the first element in it, we get 3.3 instead of 5.6. Okay. Let me quickly see if I can find the answer to that question. Uh, Java arrays source descending. Oh, hmm. Yeah. According to this Google search, there's a way to do it, but it requires importing something that's kind of you have to import something else. But that could be another problem for later. Anyway, all right, let us move on. Uh, okay, a multidimensional array is an array that contains one or more arrays. So it's like that list of listing that I mentioned earlier. So let's take a look at this piece of code and see what it does. Okay, so when we're declaring a multidimensional array, we have two sets of square brackets instead of one set. So here we have a two-dimensional array called anum that is a two-dimensional array of integers, or we could think of it as like a list of integers. So the first element of this array is an array of integers 1, 2, 3, 4, and the second element of this array is 5, 6, and 7. So it's multidimensional arrays can be kind of confusing to understand, even for people in undergrad and in college. It can be kind of hard to understand. But it's pretty intuitive. You guys get it eventually. So what we did now, we have int x is equal to anum, and then square brackets 1, square brackets 2, and then we print out x. So what this syntax means is that this first square brackets here, this square one, not square one, this square brackets one, it means we want to go to the first array in this multidimensional array. And then this square brackets 2 means that we want to go to the second element, or rather the second index of this array, which is 3. No, oh, no, sorry. I forgot that even starts at 1. So when we put in 1, we're actually going to the second list because indices start at 0. So this list here would be index 0 for anum, and this list here would be index 1 for anum. Okay. And then when we put in 2 here, we go to index 2 of this array, which is 7, because 5 is index 0 of this array, 6 is index 1, 7 is index 2. Yep, how a for loop is one way to do it. So there is a function in Java that is able to do descending sorts. All right. So that's how we access a multi-dimensional array. So as a fun little challenge, let's say that we want to access element 4 of this array, okay? Um, like this number 4 in this array. What syntax would we use to access this number 4? I want you guys to put it in the chat. I'll give you guys a minute or two. So we used square brackets 1, square brackets 2 to get 7. How would we get 4? So the way that we would get 4 is we would change this 1 to 0, and this 2 to 3. Let's see what we get. And we get 4. So why does 0, 3 work? Because this first array here is at index 0 of a num, and the 4 here is at index 3 of this first element of a num. So that's why we get 0, 3. I'm glad to see that we got a decent number of correct answers here. Yeah, the indices part can get pretty confusing. Just remember that indices always starts from 0. It was that way for strings, and it's also that way for arrays. All right, let us move on. You can quickly go to this website to see some more stuff about arrays. I'll post this in the chat too, before I forget. So these are a bunch of array functions that you can use. I wonder if sort is in here. Hmm. So apparently sort can do descending order, but I don't really see how you do that here. Oh well. So yeah, you guys could take a look at this page and look for stuff that you like. Uh, uh, all right. Now, because that was arrays, the primitive array. Now there is this thing in Java called an array list. Now the array list in the Java util package is a resizable array. The difference between an array and an array list is that the size of an array cannot be modified, while elements can be added and removed from an array list whenever you want. So we'll see an example of that. First, let's import array list and create an array list object. Oh, okay, it's on mine. Okay, so we imported array list and we use this syntax to create a mylist, an array list of strings. You have an array list of strings called mylist. Running this shouldn't really print out anything because we're not telling it to print anything. So elements in an array list are actually objects. The string in an array list is an object, not a primitive type. To use other types such as int, you must specify an equivalent wrapper class, like integer, for example. Also need to, if you want to use other primitive types, then you need to use Boolean, character, double with the capital first letter, etc. So the main thing to get across here so far is that the main difference between an array and an array list is that you can resize. You could change the size of an array list. Once you set the size of a regular array, you can't change it. But setting the size of an array list, you could increase it or decrease it however you want. And you do it with syntax like this. So if you want to add stuff to an array list, you do you use the .add method. If you want to get a specific index value, you just you use .get and then the index. If you want to change it, you use set. The methods themselves are pretty intuitive, I'd say. Let's see what happens if you were to print out my list. as I suspected. Now let's try to print out the first element of this array list. It should be F. No? Oh. Oh, interesting. Oh, I forgot to put in my list. All right, so let's try printing out the first element of my list. It should be Apple. No? Oh, that's weird. Maybe it starts at 1. No? Oh. Well, I'll have to do some investigating, I guess, later on to figure out why this isn't working. But I'll probably be in the slides later. All right, let's just move on for now. Uh, so that's how to add stuff um, to an array list. That's how to get some values set, removed. You guys can play with this later if you want. The methods themselves are pretty intuitive. Let's see, the AP Computer Science test. So an array list is one of the things that are gone over in AP Computer Science tests. So for you people that are going to go on to high school and take AP Computer Science, this stuff will come in handy. All right. So before I move on to dictionaries, does anyone have any questions about what we've seen so far? All right. Okay. And I think I've also figured out why the get method didn't work for us earlier. Yeah, okay. Okay, so going back to the code, the reason why it didn't work earlier was because we ran this line here to clear the array. So this is actually a pretty handy function, this this clear function, if you want to just erase all the elements of an array. Uh, I'm not too sure what size does off the top of my head for an array list, but yeah. So lots of work with here uh, with array lists. So okay, let's move on to dictionaries. A dictionary is an abstract class that stores key value pairs. Given a key, its value can be stored and retrieved. Thus, a dictionary is a list of key value pairs. Also say that you map a key to a value. So what does this all mean? Well, the main difference between a dictionary and an array is that um, in an array, the key is the index value, but in a dictionary, the key is whatever the programmer wants the key to be. So it maps any key to any value. Now, see a hash table. Now, a hash table is an implementation of a dictionary. According to the slide, hash table was part of the original java.util, and it's a concrete implementation of a dictionary. So this code right here is how to create a hash table, or the syntax to create a hash table. Let's try to run this and see what we get. Well, he has no idea what a hash table is. Yes, it does not. All right, let me quickly check what I need to import for a hash table in Java. Okay. There we go. Okay. So I need to import java.util hash table. So if you were to run this, Java won't complain at all. Well, this is the syntax for declaring a hash table in Java. Let me just go through it. So in this first one for H, the key is an integer and the value is a string. for this hash table, which is a type of dictionary. And for this, and it's the same thing for H1, the key is an integer and the value is a string. So any particular value in either of these hash tables will look something like 5 cats or 14 Kingsley, something like that. It's going to be an integer followed by an integer for the key and a string for the value for this hash table dictionary. All right. This is how we use the hash table. Let's run all of this and see what we get. So a lot of it is similar to the array list, except we're putting in the key and the value. So let's run this code and see what values that we get. So values in 1 is important. That's because of this here. And we're doing h.get1. So the first index, or actually I think it seems like for hash maps, the counting starts at 1 actually. So that's why we get is important, which is a string. Let's see. We could also use h.values to get all the values in the hash map. Enumeration, you can use enumeration to get all the keys, so on and so forth. The methods are again pretty self-explanatory. Can you put a different value for the same key? Let's see what happens if we put a different value for the same key. So I guess that's going to be something like h.put 1 is not. Ooh, why is this thing being stubborn? Is not important. Let's try changing the key value and see what happens. All right. So it changes without any complaint. But before it was is important, now it's is not important. That's what happens if you change the value for the key that's been already set. So a hash table and an array list is more flexible and powerful than the primitive, than the stock really Java array. You could do more with it and it's cleaner, but that doesn't mean that it's always better though. See what we have here. So to create a clone or a shallow copy of a hash table, that's also possible. What is this complaint? Oh, okay. So this code block right here gives an example of cloning one hash table into another. Values in clone. We may have to try uncommenting this and see what happens. Okay. All right. So looks like what we did was that after we put some elements in H, we made H1 equal to a clone of H using the dot clone method. Then we print out the values in H1, which is the same thing that it is in regular H. And then we clear H. And then after we clear H, when we print out H again, it's just empty. Well, in H1, it's still the same. So this code block may take a minute to parse, but what it's doing is pretty intuitive, I'd say. So does anyone have any questions about hash tables, array lists, anything else that we've gone over so far?
Wait, can you say what hash tables are for again?
Yeah. So hash tables are one way to implement a dictionary. So hash tables takes a key and a value. The key being whatever we want and the value being also whatever we want. So we declare the hash table up here where the keys are an integer and the values are a string. So if we were to try to put, say, like a double into the key, it would give an error. Um, and this line here is an example of us putting in stuff into H, which is a hash table that takes an integer as a key and a string as a value. We put in 3 as the key first, and then grade as the string value. In the second line here, we put 2 as the key, and then for class as a string, and so on. So yep, that's what a hash table is. It's just Java's implementation of a dictionary. Alrighty. Let's move on. Okay, we have a little quiz here. What's the main difference between an array and an array list? Oh, let's see. Okay, can you define hash table with a key that is not an int? Yes, you can, Minwan. Let me quickly give an example. Uh, so we can make the key double and the value string, or int rather. Oh, you didn't like that? Integer, really. So let's try putting something into H2. We need to put a double, let's say 8.42 foot, whatever that is. And then an int, we could put 50. And then we could print out H2. Yep, and then just prints out the key and the value. So yeah, there are ways to uh, make the key and value of a hash table whatever you want. Good question, Minwan. All right, looks like we got a few quiz answers already. The main difference between an array and array list. The main difference is that you can change the number of items in an array list. So that's the main difference. So you can increase it or decrease it. Looks like some people got that answer. Good job, Aaron, Angela, Vincent. Okay, another quiz. Which of the following declares an array of integers named img? I'll give you guys a minute to figure this one out. All right, so the correct answer is indeed B. This was an easy one. Good job, guys. Let's see, another quiz. What is the output of the following code fragment? So we have an array of integers that's equal to 2, 4, 6, and 8. And then we're changing index 0 to 23. And we're changing index 3 to be equal to index 1. And then we're printing out index 0 and index 3. So I'll give you guys a minute to figure out this one. Right, so the correct answer is D. We can quickly verify this. Oops. Twenty-three and 4. It looks like most people got their correct answer here. Does anyone need any explanation as to why we got 23 and 4? This one tests our understanding of array indices. The main thing is to remember that array indices start at 0. All right. Next quiz. Which of the following applications is an array not suitable? Uh, and then you have A, B, C, and D there. I'll let you guys read that. Now we want to know which one of these is not suitable for an array. Okay, the correct answer is B. Now, can somebody tell me why the correct answer is B? Yeah, the correct answer is B because they're different types essentially. We have name, which is a string, social security number, which is an integer, age is an integer, income is an integer or a double. So arrays can only take one type. It can only be one type. So it has to be all strings or um all integers, all doubles. So that's why B wouldn't be suitable. Very good, everyone, and especially very good to Sophia. I'm really proud of you guys. All right, next quiz. Examine the following code. Array list, strings equal to new list. So we're working with array lists now, and then we're adding some values. Now, after the code is executed, what is the capacity of the list and what is its size? Oh, I'm not sure if we've gone over this yet. Well, actually, you guys ought to be able to answer this. So we want to know the capacity and the size of this list. So take a close look at the list declaration and how many elements we're putting into it, and you'll be able to answer this question. All right, the correct answer should be, what's the correct answer? I think it's C? Yeah, it should be C. What did you guys say? Okay, good. You guys also said C, so I must be right. Okay, the correct answer, we have decided that it is C because the capacity of this array list is 10 because that's what we're putting up here as an argument when we declared it. And then we put in 3 elements to it, so its size is 3. That's why the answer is C. Right, one more quiz. What is the output of the following code? Of the code fragment, we are declaring an integer array 2648, and we're printing out the element and the first index, or the element and index 0 and the element and index 1. This one is pretty straightforward. Right, the correct answer is C, because 2 is an index 0 and 4 is an index 1. Alrighty then. Collections. The data structure that we have learned today has one, or the data structures that we have learned today has one thing in common, is that they are a group of items. These kinds of data structures in Java have a term, collection and map. So these two links here talks about what collections are and what maps are. Take a look at them as you please. I'll post them both in the chat, and I'll post these in the Google Classroom later on as well. So the collection interface and the map interface are the two main root interfaces in the Java collection classes. So interfaces are kind of an advanced topic, so we'll be talking about that in the future. Yeah. Let's see. So I guess the slides that follows are kind of just bonus. They're kind of more advanced Java, more advanced object-oriented programming kinds of stuff. So if the terms used here are kind of foreign, don't worry about it. It's just a fun little thing that might be interesting. So when Java was first invented, the standard method for grouping Java objects or collections were arrays or vectors or hash tables. So we've gone over arrays and hash tables today. These collections had no common interface. Accessing elements had a different method and syntax, as we've noticed. So another weakness is that most of the vector methods are final, meaning we cannot extend the vector class to implement a similar kind of collection. That's object-oriented stuff. So to correct these problems in a JDK 1.2, the collection framework was introduced. Both legacy vectors and hash tables were modified to conform to the collection framework. So collections we could think of as just fixing problems that were present in arrays and array lists and vectors and hash tables and all that. Now, the advantages of the collection framework is consistent API. So instead of having all these different ways to use array lists and linked lists and vectors and hash tables and stuff, the collection interface has one common set of syntax, really, that they all use. It reduces programming effort because you don't have to worry about the design of the collection. It increases speed and quality, increases performance. Just makes things a lot easier using the collection framework in Java, but it's kind of advanced, so I won't talk about that here. See, the collection framework has methods like add, remove, contains, is empty, add all. Pretty self-explanatory. Let's see. So the set collection does not allow duplicates. So that's essentially the main thing about sets. They don't allow duplicates, everything. So you can have 3 elements that are set to 3 or something. So a list can contain duplicates and elements are ordered. A queue is a type of list where things are put in first out order. See more things about collections. You have dequeue, which is a method in the collection class. You have map. The difference between set and map interfaces is that in set we only have keys, whereas in map we have key value pairs. So an array would be an example of a set. Well, at least in key terms, because 2 elements can have the same index value. And a map is an example of like a hash table or something, or a dictionary. So kind of advanced stuff. I won't be testing you guys won't be testing on collections or anything. This is more for object-oriented programming. It's just one advanced topic of Java that we thought we could tell you guys about. All right, homework. So for this homework, we have an array, or we have two arrays. One is a string array, and a list of strings, and the other is an integer array. So your homework assignment is to write code to remove the shortest item in this in the first array. So shortest meaning like the length of the string. So one thing you could think about is using the length and the string to create a new hash table. And then use the length to create a new array and then sort it. So that may require using the sort method. And also remove the first item from this array after you sort it. And then, wait, no, this is the, okay, so that was all the hints actually. So your first objective is to write code to remove the shortest item in the array, and the things in the parentheses here are just tips that you can think about. And then next, remove the largest value in the second array. So the largest value for 10, 5, or 2. And then order those two arrays in ascending order independently. And then after that, use these two ordered arrays to create a hash table. The item from the first array is the key, and the value from the second array is the value. Finally, print out the second value using its corresponding key. So a few things in this homework assignment. This may take you guys a minute or two. I'll try to write up the solution to this so that I have a better idea of what you guys will be working with. But yeah, does anyone have any questions about anything we've gone over in class today before I let you guys go? Oh, all right. Okay, guys. Thank you guys for attending this class, you guys and girls. We have 2 more classes left. Well, 6 weeks have gone by like that. Aditi has a question. Is there a max array number limit? Yes, technically, the max that an array can be is the amount of memory that you have in your computer, pretty much, which is a lot of bits and bytes. But yeah. All right. Any other questions? All right. Well, you guys have a good evening, okay?